Okay, guys, we are on day 3 of the Unit 5 and 7 combined mashup, where we're going to be talking about similar polygons and triangles, but more specifically now we're going to talk about how you prove triangles similar. So this is the Unit 7 Lesson 2 notes, and then of course we have some workbook pages to go with it, page 191 and 193. It's really quick. Hopefully you guys will get this and be able to move on to day 4 and section 3. So we'll go ahead and get over to the notes. First question I want to ask you are, what are the 5 methods of proving triangles congruent? Go ahead and pause the video and see if you can write down the 5 methods. When you unpause, we will have the 5 answers. Okay, so hopefully you remembered from Unit 4 that side, side, angle, side, angle, angle, side, and hypotenuse leg are the 5 ways that you can prove triangles congruent. Now, there are less for similarity. So what are the minimum requirements for triangles to be similar? We talked about this in Lesson 1. The angles must be congruent. Angles. And the sides have to be proportional. So, because that happens, there are only 3 ways to prove 2 triangles similar. The first is angle-angle similarity. If 2 angles of one triangle are congruent, then the triangles are similar. Now, we know this is true because we've talked about this in the past. If this is a 60-degree angle, and this is a 60-degree angle, if this is a 70-degree angle, and this is a 70-degree angle, what has to be the third angle for both triangles? Well, 60 plus 70 is 130, so 50 degrees has to be the missing angle here. 60 plus 70 is 130, so 50 degrees has to be the missing angle here. Now, they are similar and not congruent because we don't know anything about the length of the sides. Okay? And because we don't know anything about the length of the sides, then we can only say that they are similar. And these 2 are similar by angle-angle. Now, what also makes similarity really cool and easy is because it's more direct. There's not a whole lot of guessing, like, angle side angle and angle side. We're giving you guys problems up here, and so did hypotenuse leg. But in similarity, we have angle, and then we have side, side. If the measures of the 3 sides of 2 triangles are proportional, then the triangles are similar. So, if this is 4, and this is 8, and this is 12, and this is 5, we have a ratio, like we talked about in last section, of 4 to 5. So that means that this side has to be 10, and this side has to be 15. So these 2 triangles are similar by side proportionality. Okay, then there's one other way, and it's side angle side, which is good because that's the one you guys are most familiar with. And it basically says that the measure of 2 sides of a triangle are proportional to the measures of 2 corresponding sides of another triangle, and the included angle, and remember we talked about that with side angle side and angle side angle, the included angles are congruent, then the triangles are similar. So this is important. I have 2 triangles, they share an angle in common. This side is 6, this side is 12. If this side is 12, well, we have 6 to 12 ratio, or 1 to 2, so then this side has to be 24. And now we can say that these 2 triangles are similar by side angle side proportionality. Okay, So now we want to go to the back and we want to determine whether the figures are similar and then justify your answer. So the three options are going to be they're either similar by angle, angle, side, 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 or side, angle, side. Obviously, you can tell which way these are going. Do you see any angles here? They must be trying for side, side, side. Do you see any angles here? They must be trying for side, side, side. One angle, so they must be trying for side, angle, side. Two angles, they must be trying for angle, angle. In order to check to see whether or not they work, you have to show that two angles are congruent, or one, and then you check for side proportionality. So go ahead and check 1 through 4, pause the video. I'll have the answers for you when you're done. Okay, so when we looked over the 4, if you notice number 1, I had 9 to 12, 14 to 20, 13 to 21. They don't reduce to the same proportions, so these two triangles are not similar. Okay. In number 2, I had 6 to 8 and then 9 to 12. All of these reduced to 3 to 4. So these two triangles are similar by side, side, side similarity. In number 3, I have the angle that's included, and then the sides are 10 to 15 and 14 to 21. So by a ratio of 2 to 3, these are side, angle, side similarity. And then for number 4, I have 30 and 60 and 90, 30, 60, 90. So I have at least two angles that are congruent for each one. So that is angle, angle similarity. Now, we call this the proportion unit. The reason why is because if two triangles are similar, you can set up a proportion to solve for a missing variable value. So for AC and ED, if I want to solve for the missing lengths, I need to set up a proportion. Well, what is the relationship between this triangle and this triangle? Well, let's look at the corresponding parts. In between the small angle and the right angle, there is a length of 15. On the smaller triangle, in between the right angle and the acute angle, there is a length of 12. There is my base ratio, 15 to 12. And so I can say 15 over 12 is equal to x plus 5 over x plus 1. Then I can cross multiply and use this information to solve for x. And so when I solve for x, I get 3x is equal to 15. Oop, this is 12x plus 60. So 3x is equal to 45. And so x is equal to 15. And so then when I plug 15 back in, ED is 20 and AC is 16. And I kept my ratio of 5 to 4, or 15 to 12. Where it gets a little bit more difficult is when we have two triangles that are part of one another. And so a lot of times to handle this, we have to draw a picture that's separate from the big picture. So this little triangle in here has a base of 6. The big triangle has a base of 12. There is our base ratio, 6 to 12. In order to solve for x, we have to compare this side to the whole side. Well, this side is x plus 5. Here's where the mistake is made. The big side is this whole length over here. So what do I do to these two things in order to show how much the length is? I add them together. And so x plus 5 plus 9 is x plus 14. And so again, I can do x plus 5 over x plus 14. We cross multiply. 6x plus 84 is equal to 12x plus 60. 24 is equal to 6x. X is equal to 4. And so we find that if x is equal to 4, 4 plus 5, that is 9. And so if we're trying to find this measure, then we know EH is also 9. And so then the length of EF is equal to 18. So again, just different ways that we can prove two things proportional. This completes the notes for this section. In the workbook, we are supposed to be going to page 191, 1 through 6, and 193, 1 through 4. So I'm going to go to page 191. 191 is just like the first sets of examples that we did in the notes. So on 1 through 6, you have to tell me whether or not the triangles are congruent, or similar, I'm sorry. And if they're similar, which method? So is it going to be angle, angle, side, 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 or side, angle, side? Okay? Now, if you can't prove that they're similar, you have to show me why you can't prove them. So either there's not enough information or whatever we've got going on here. Now, I will tell you there's one thing that you have to do, just like with congruency. You have to add information. So number one, we can add vertical. The other thing that is true, do you see this little arrow here? We haven't discussed this in the past, but we're going to discuss it now. These are things that show us that these lines are parallel. So if these lines are parallel, angle C is congruent to angle B. Angle A is congruent to angle D. Okay? Over here, these two angles are congruent. Okay? So again, you're trying to prove, is it angle, angle, side, or side, side, side. So the same thing we looked at before. And then on page 193, 1 through 4, again, it's the same thing. Which ones can be proven, find the values, missing values, set up the proportions, solve the ratios, etc. Really pay attention to number 4. This is a crucial aspect of this chapter. Setting up a ratio to solve for a missing amount. Okay? Any questions? See me once you're done with those 10. If you want to do the advanced problems, I certainly suggest them. But I'll check it off, and then you'll move on to section 7.3.